Hello everyone, today I'll be presenting the solutions to 2018 SMO Senior question 14 to 19. So for question 14, we are given a quadratic function and the values f1 and f2 are bounded between some numbers. So we're asked to find the largest possible value of f4. So if we evaluate f1 and f2 using the formula given, we can express f1 and f2 as a minus c and 4a minus c respectively. And similarly, f4 is equal to 16a minus c. So you know that f1 and f2 are both linear combinations of a and c, and so is f4. So that means it's possible to express f4 as a linear combination of f1 and f2. And if you play around, you will get f4 equals to 5f2 minus 4f1. So using the bound, we can get the maximum value is 30 plus 12 is 42. For question 15, we are given some absolute value less than or equal to x minus 1, and we're asked to find some answer extraction because the answer will be a fraction. So first thing to note is that the thing in the absolute value will always be greater than or equal to 0 because it's an absolute value. So that means that x minus 1 is greater than the absolute value of this thing is greater than or equal to 0. So that means that x is greater than or equal to 1. And since x is greater than or equal to 1, x plus 9 absolute value is equal to x plus 9 itself. That means that we only have to care about the x minus 9, absolute value of x minus 9 term. That is the only thing that actually changes. So firstly, we're going to take x less than 9. So we will have absolute value of x minus 9 is negative of x minus 9. But because there's a minus sign in front of the x minus 9 over 10, we can express this as plus x minus 9 over 10. So we can simplify the expression inside the absolute value and we'll get x over 5. Because absolute value of x over 5 is less than or equal to x minus 1, we can obtain x is less than or equal to 5 over 4. And remember how we put case 1, x less than 9, we don't actually need to move on to case 2. Why is this so? Because the question asks for the smallest number satisfying the inequality. And we already have one working number, 5 over 4, x less than or equal to 5 over 4, in the first case. So that means that we don't actually have to bother, and a equals to 5 over 4. So n plus n will be equal to 9. For question 16, we are given a polynomial of degree 4, and we are given its values for n equals 1, 2, 3, 4, and 5. So because px is a polynomial of degree 4, that means it has 5 different coefficients. For x to the 4, x to the 3, all the way to x to the 0. So that means that we can actually uniquely determine this polynomial using the given information. So if we can theoretically form 5 different linear equations in 5 variables, which is nice, but this is obviously going to be very tedious. So that is obviously not the method that is intended. So we're going to consider the polynomial qx equals xpx minus 120. Why is this so? Because we know that pn over n equals 120. So that means that xpx minus 120 will be simply 0. And from this polynomial is clearly degree 5 because px is of degree 4 and we multiply it by x. So as I said, it has roots at 1, 2, 3, 4, and 5. So that means that it's k times x minus 1, x minus 2, all the way to x minus 5, where k is a real constant. So from this form of qx, it's clear that the constant term is negative k times 1 times 2 times 3 times 4 times 5, which is negative 120 over k. However, from the form that we use to construct qx, which is xpx minus 120, it's clear that the constant term is negative 120 because when you multiply px by x, all of the constant term will become at least, it will have the degree of x will be at least 1. So negative 120k will be equal to negative 120. So that implies that k equals 1. As such, Q of x will be equal to x minus 1 times x minus 2 all the way to x minus 5. So when x equals 6, we can just substitute in and we will get 5 factorial. And then P of 6 will just be Q of 6 plus 120 divided by 6, and if you sum it in, you'll get 40. Question 17, we're given this massive sum, and we're asked to find the largest integer which is smaller than or equal to L. So this is basically the floor of L. And this, we're obviously supposed to somehow simplify the expression inside the sum, probably using some telescoping method, so that we can actually find a closed form expression for L. So we're going to use the identity tangent of a minus b is tangent a minus tangent b over 1 plus tan a tan b. And then we from here, we can swap around the denominator and the left hand side. We will get an expression for 1 plus tangent a tangent b. So L, you see that is actually in the form 1 plus tan a tan b, and you can use the formula and you will get something over tangent 15, and 1 over tangent 15 is a constant factor, so you can drag it out, and the remaining sum is a telescoping sum. So you can simplify it as follows, and you can use the fact that tangent of x is equal to tangent of 360 degrees minus x, and you can simplify it to be 2 times the square of cotangent 15. Now we want to find a closed form expression for tangent 15. So we can use the same tangent a minus b. We will get tangent 15 is tangent of 45 minus 30. And since tangent 45 and tangent 30 are both very easy to obtain, we can get tangent 15 is root 3 minus 1 over root 3 plus 1. So that means that L is 2 times cotangent 15 degrees is 2 times the square of square root 3 plus 1 over square root 3 minus 1. So it only remains to expand this expression and rationalize the denominator, and you will get 14 plus a root 3. We are asked to find the floor of L. So we can use the approximation root 3 is about 1.73. Since you know that we are using 2 decimal places, the difference between root 3 and 1.73 will not affect the floor. So we can get the answer is 27. For question 18, we're asked to find the smallest 3-digit positive integer whose square ends in the digits 1 to 9. Okay, so for question 18, it's actually a very straightforward question in the sense that the approach is very intuitive and straightforward. So we can let n equals 100a plus 10b plus c, where a, b, and c are its digits, obviously. So using the binomial theorem, or in this case it's a trinomial, but anyway, when you expand n squared, you'll get this expression, and we can take modulo 10 and modulo 100. So when you take modulo 10, all of the terms except for c squared will disappear. So that means that c squared is congruent to 29 modulo 10, but 29 is just 9. So c squared is 9 modulo 10. And similarly, by taking modulo 100, only the last 2 terms are left. So 20bc plus c squared is congruent to 29 modulo 100. So from c squared is 9 modulo 10, you can get that c is 3 or 7. So if you substitute this into the second equation, both cases actually you b equals to 2 or 7. And similarly, a will be equal to 1. So basically this is just a big case bash. And after you do all that, you will check that 123 is the smallest integer that satisfies c is 3 or 7 and b is 2 or 7. So you can just double check to be safe. You check that 123 squared satisfies the condition. So 123 is the answer. Okay, so question 19 is a geometry problem where we're given an angle bisector and a tangent line to a circle, and we are asked to find a certain angle given that CEA is 22 plus angle BAP. So this is the diagram, and line AP bisects angle BAC. Because we're given that BAP equals to y, PAC will also be equal to y. Now the approach is we let x equals to the angle CAE, and by the alternate segment theorem we can obtain angle ADE is also equal to x because AF is tangent to the circle. So we can consider the triangle ADE. So in triangle ADE, the angle ADE is x, and the angle DEA is equal to 22 plus y. Because in the question it's given that is angle CEA is 22 plus y, but CEA is just DEA. And the last angle, which is DAE, is equal to the angle DAC plus CAE. And we let x equal CAE already, so CAE is taken care of, that is just x. And DAC is equal to y because the line AP bisects the angle BAC. Hence 180 is equal to x plus 22 plus y plus x, which is 2x plus 2y plus 22. So if you solve this, you'll get x plus y is 79 degrees. Now I want us to find the angle APC, and we know that this is equal to the angle PBA plus the angle PAB because it's the sum of two interior angles is equal to the exterior angle. So we know that PBA is equal to y because PBA equals to CPA equals to CDA, and CDA is just x, and meanwhile PAB is y. So the angle we're asked to find is just x plus y, which is 79 degrees. So we are done. So thank you, and I hope you found this solutions useful.